Hi everyone, in this video we are going to be talking about finding the least common multiple and the greatest common factor. So we are going to be talking about this in terms of just numerical values and what that looks like when we start using exponential expressions and finding the least common multiple and greatest common factor of those. So our least common multiple is the smallest positive value that is divisible by each number or expression. So when we're talking about multiples, essentially what we're looking to do is add that number to itself multiple times. And the least common multiple is going to be the smallest number that two values share in common. Our greatest common factor is the largest positive integer that divides evenly into all numbers with zero remainder. So factors are those numbers that we look at. They multiply to be our positive integer. So for example, if we have 6, factors of 6 are 2 and 3 because 2 times 3 is 6, or 1 and 6 because 1 times 6 is 6. So what we're looking for is between two numbers, what is the greatest number of those factors that those two numbers are going to share in common. So let's look at an example. What is the GCF of numbers 12 and 18? Well, what we want to do when we're looking for the greatest common factor is we want to list out the factors of those numbers. So we're going to identify those numbers. So 12 is 1 times 12, 2 times 6, 3 times 4. Oftentimes, I like to kind of write it working downwards. And I work from least to greatest. So I'll write it as 1 and 12 are a pair because they're a product of 12, 2 and 6 are a pair, and then 3 and 4 are a pair. Same thing for 18. 18 is 1 and 18, 2 and 9, and 3 and 6. And then we need to identify, what is the largest number that they both have in common, hence the greatest, largest common. They both need to have it. Factor, well, we're talking about factors. Well, that's going to be 6. So the GCF of 12 and 18 is going to be 6. We can follow a similar process for the least common multiple, except in this case, instead of listing out the factors, so numbers that are going to multiply to be either 12 or 18, we're going to list multiples of 12 and 18. So what happens when we multiply 12 times 1 or 12 times 2 or 12 times 3? Or we add 12 to 12 and then add another 12 and then add another 12. So our multiples of 12 are 12, 24, 36, 48, 60, 72, 84. For 18, 18, 36, 54, 72. Well, now since we're dealing with least, we need to identify the smallest number that they share in common, and that smallest number that they share in common is 36. So the LCM of 12 and 18 is 36. Now, we can do this exact same thing, with with exponential expressions. So how I like to do these is I like to work number by variable by variable. So let's start here with the GCF. So the first thing we need to do to identify the GCF, is look at the factors of 4 and 30. So 44 is going to be 1 and 4 and 2 and 2. 30 is going to be 1 and 30, 2 and 15, 3 and 10, and 5 and 6. What is the greatest common factor that they share? That is going to be 2. So the numerical part of your GCF is going to be 2. Now we can do the same thing with x and y. So the greatest common factor. So if we're looking at the common factors of x squared, we have an x times x. But for x, our greatest common factor is x. So when we're identifying the GCF with variables, we're looking for the fewest x's, because that is going to be, how many x's that they share in common. Okay, so here they each have an x. Okay, so there's going to be one x in your GCF. And then the same thing with the y's. Okay, the greatest common factor, well, y squared is y times y times y, or y squared is y times y, well, y cubed is y times y times y. Well, what's that greatest number of y's they share in common? They both have two y's in common. Okay, so that is why we have one x and two y's, because the greatest number of x's they share in common is 1. The greatest number of y's they share in common is 2. Okay, we can follow the same path with our LCM, our least common multiple. So we need to identify the multiples of 4. Okay, 4, 8, 12, 16, 20, 24, 28, okay, 32. We're going to have to keep going because it's 30. Okay, I'm going to tell you, we can keep going. The first number they're going to share in common is 120. And the reason I know that is because my least common multiples, my multiples of 30, are 30, 60, 90, 120, 150. So I can check to see if these are divisible by 4. Well, the only one that's divisible by 4 is 120. So 120 is going to be our first piece of our LCM. Now we move to our variables. So our x's, we have x squared, x times x, okay, and our x is just x. So we're looking for our least common multiple. Well, here we would list the multiples of x squared and x to the fourth. So the multiples of x squared are going to be multiplying additional x's here. So it would be times x times x times x. Well, for our x, our 1x, we can do times x times x times x. The first time they share the same number of x's in common is going to be at x squared. Okay, or again, a trick with the LCM is we're looking for the most x's between them and the most y's between them. Okay, that m helps us deal with our variables. Our L for the least helps us deal with numbers. Same thing for y. We have a y squared and a y cubed. Well, we notice, okay, to find our multiples, we just keep multiplying against multiple by y, and we can easily achieve that by multiplying our y squared by y to get our y cubed. And that's the first time they are going to share y's in common. So it's y cubed. Okay. We will talk about this more in class. We'll look at some tricks to identifying those. But if you have questions, please make sure you ask. Have a good day.